The distributive property is talking about multiplication. And what it represents is having a way to multiply. Let me give you an example of something. So I'm going to throw a math problem up here. If I threw this math problem up there and I said, hey, solve this, well, you would use the order of operation to solve, of course, because there's more than two items. You always follow the order of operation. So you would say 2 plus 5 is 7. So this is actually 3 times 7. And 3 times 7 is 21. And I would agree to that. Now, there is another way that you can multiply and still come up with the same result. You can do something called distribute. Let me show you what that means. I'm going to start with the same math problem. Distribution says this. Hey, if I'm going to take the 2 and the 5 and add them together and then multiply by 3, it's the same thing as if I took the 3 and multiplied it times the 2, and then I multiplied it times the 5, and then I combined them. Look, let's give it a shot. 3 times 2 is 6, plus 3 times 5 is 15. 6 plus 15 is 21. That's called distribution. You notice they're both the same. So the thing is this, is that you would never use distribution with something like that. It would be a waste of your time and can cause confusion. You just follow the order of operation. But this is where the issue happens. It happens when you're multiplying, for instance, like this, and you're multiplying with an unknown. Well, you can't do this kind of multiplication because it's just not going to work out. You don't know what that unknown represents. But you still need to have some technique or some method in order to continue working the math problem. And what they do is they say, we're going to distribute. What it allows us to do is to break this up and to continue the math. So let's give it a shot. Notice that with the 3, you would be multiplying it times the x. Now, 3 times x, you would say 3x. But I'm going to show you something else. Every time you see a variable sitting by itself like that, there's always a 1 in front of it. So really what's sitting there is 1x. And 3 times 1 is 3. So what you can say is 3 times 1x is 3x. That's why it's written here. And then you would take the 3 and multiply it times the 1. 3 times 1 is 3. So 3x plus 3. You want to try again? Let's take this 4 and distribute it across. Ready? 4 times y, 4y, plus 4 times 2, 8. Good job. Let's try another one. Now, notice this time, you're going to be using a negative number. You need to remember that. So this is going to have to use your rules of integers. So this is negative 3 times 1x, or positive 1x. So 3 times positive 1x, did you say negative 3x? That would be correct. Plus 3 times positive 1y, did you say negative 3y? I would agree with you. Let's try again. See this negative 5? We're going to multiply it across again. Negative 5 times positive 2x. Did you say negative 10x? Agreed. Plus negative 5 times positive 1. Did you say negative 5? I agree. That's what distribution is. So let me show you something else. This is the one that really starts to confuse people. I want to give you a demonstration of what this means. Okay? If I took a 3 and I multiplied it by a 3, you would say that that is a 9. And I would say yes. But also another thing too, isn't this number times itself, isn't it same thing as writing this? And isn't this the same as that? hopefully you would say, yeah, that's true. If you took 3 and multiplied by 3, it would give you 9, but it's also the same thing as saying 3 to the power of 2 because it represents the exact same thing. So let me show you what's going on over here because this can be quite confusing. This represents some number. It's unknown, but you're multiplying it times itself. Well, that's what this means. This means taking a number and multiplying it times itself twice. Well, x times x is the same thing as saying x squared. These should be the same, shouldn't they? Hopefully you say yes. That's x squared. Let me give you another thing. What if I showed you this? X times x times x. Well, isn't this x times that the same x squared? I would say yes. Now, what if I took x squared and multiplied it times another x? Well, isn't that x times x times x? Isn't x times x times x the same thing as saying x times itself 3 times? And hopefully you say, yeah, x times x times x is x times x squared times another x. That's x to the power of 3. That's what happens when you multiply unknowns. Let's give something a shot. Look at this guy over here, okay? You notice that this is a 2 and an x, and you're multiplying it times another 2 and an x. So 2 times 2 is 4. Now what about x times x? Oh, isn't that x squared? Yes, it is. Now, plus, let's keep going. What about 2x times 3? Well, the 2 times the 3 gives me a 6, but doesn't it still have an x attached to it? And the answer is yes. Is it squared? No, because the first one was an x and an x being multiplied, not the second number. Continue.